Grade 10s and grade 11s. Um, this is an electric circuit question, mainly on grade 10 and grade 11. But it can also help the grade 12, but it doesn't have the internal resistance. It says, study the circuit below. The battery has an EMF of 12 with a negligible internal resistance. Voltmeters and ammeters are connected in a various position in the circuit. Now let's look at the circuit. It's very important, guys, to look at the circuit. What's happening here? Now in this circuit, guys, when the switch is open like this, the reading here, the battery, we are told the voltage of the battery, it's what? It's 12V. So when the switch is open, guys, there will be no current. The current will pass from this side, not to this side. It will pass from this side to this side. But since the switch is open, there's a gap there, so the current won't be able to. So the only thing here, the only meter here that will read, it's this voltmeter one. It will read the 12 volts, which is the EMF. It reads the EMF, right? Now when the switch S is closed, this switch S is closed, there will be a current there. That current will move from there. It's a total current. It goes there and it goes there and it goes there. So that means this ammeter reading, now there's a current that passes there. It's the total current. So that current, it passes there and it passes there. But when it gets there, there's a split. There are two pathways. There's a current that will go that way, and also there's a current from that total current. There's a split there that will go there, and that current passes there, and then it goes there, and this current will pass in that 6 ohm resistor, and this ammeter reading will read this fraction of current that passes there. Right, so now you need to understand what is happening here. There's a split of the current, and which is the split of the total current, and then this current, when they get here, they join again to form that total current again. They join to form that total current again there, and yeah. So, and then that current passes that resistor. So the current that passes this resistor, it's the total, and then it goes back again to the battery and do that all the time. So now we can conclude that this circuit, it has a parallel where there's a split, and it has a series resistor. So this is a combination of series and parallel, right? So this is a total current that reads here, and this ammeter reads the current that passes here, and this voltmeter is connected parallel to this resistor, so it reads the voltage of the series resistance, right? Very important. Let's go to the questions. Define the term EMF of the battery. When we talk about the term EMF of the battery, is the voltage of the battery. In the nutshell, voltage of the battery when there is no current flowing through it. So when there's no current flowing here, this the voltage here in this voltmeter is an EMF when there's no current that it passes through the battery, right? But in grade 12 we get to define the EMF as the total energy, as the total energy provided by the battery per coulomb per charge passes through it, right? That's how we define it in grade 12. So it's very important, but it says the same thing, but this one is not allowed. This is the one that is allowed. By the way, it has to be the exam guideline. Now it says, with the switch as open, write down the reading of the following. The reading of V1 when the switch is open, I already mentioned, it's going to be 12V. It will read the battery. Right? Now, ammeter 2, what is the reading on ammeter 2 when this switch is open? It's going to be 0. There will be no reading here. There will be no reading here. It's going to be 0, 0. And also here, it's going to be what? 0. This is the only reading that will read is the one that is in the battery because there's no current that passes there. Now, they said switch S is now closed. Calculate the current in A1, which is the current in A1, guys. As I've mentioned, the current that passes there, it's the total current, right? It's the total current. So now, in order to get that total current, guys, here the current that passes here, it's the current of the entire circuit, so it's the total. So what I need to do there, guys, I have to calculate the total resistance of the circuit and use the total voltage of the circuit to get the total current. So I hope that makes sense, guys. And it's 6.1.3. I'll start with the total resistance, but let's label these and say this is R1 and this is R2 and this is R3. I hope, guys, you remember that. So I'll start with the parallel ones. So the parallel is equal to R1 times R2 over R1 plus R2. You only use this formula, guys, in two resistors. So R1 is 6 and R2 is 4. 6 times 4 divided by 6 plus 4. So punching that in the calculator, divide by 6 plus 4, so it's going to be 20. 6 times 4 divided by 6 plus 4, it's 2,4 ohms. That's the parallel, and then the series, we only have the one resistor in series there, so we'll say the R total is equal to R series plus R parallel, and then the R parallel there is the R3 plus the R parallel, which is the R3 is 1.6. It's 1.6 plus 2.4. It gives us the 4 ohm. Let me double check. Yeah, 4 ohm. Right, the total resistance. So I told you that when you want the total current, using this formula, I is equal to V over R, when you want the total current, you use the total voltage and the total resistance. So my total voltage there is 12. It's 12 volts. It's the one that is here on the battery, the one that you were given there. It's going to be 12 volts divided by 4. It's going to be what? 3 amperes. That means the current that reads here is 3 amperes, the total current of the circuit. Now let's go to 6.1.4. It says, hence determine the reading of V2. Where is V2? Which means the reading of this voltmeter. Remember, guys, what do we have here? We have the resistance, and what else do we have? It's the total current. We calculated the total current, so the current that comes there, it's 3, and then the 3 splits there, and then it joins again there, and it's 3 there again. So the current that passes there, it's 3. So in 6.1.4, we have a resistance there, it's 1.6 ohms, and what we are looking for, the voltage there, which is V2, and we have a current that passes there, which is it's 3A. So the formula that we're going to use there, it's going to be R is equal to V over I, and then we have a resistance there. The resistance there, it's 1.6, and then the V, which is V2, the one that we want, and the current, it's 3. So basically it's 1.6 times 3. When you cross multiply there, you have V2 is equal to 4,8 volts. So the voltage that is utilized here it's 4,8 volts. So the reading here is 4,8 volts. And then let's go to the next question. We're done with that. Calculate the energy dissipated. The word dissipated means used. Energy dissipated in 6 ohm resistor in 2 minutes. Okay, right? So what are we going to do in 6.1.5? Right, is it 6.1.5? Yeah, so we want the energy. What do we have in the 6 ohm resistor in 2 minutes? Which is, we want the energy that is used here, the energy that is used there. So what do we have there? We do not have the voltage there, but we can find it, and we do not have the current there, but we can find it if we want it as well. So but we want the energy. So what we're given so far, we want the energy, we're given time, which is just 2 minutes. 2 minutes is equal to 120 seconds. It has to be in seconds. And from that, what else can we, the current there we do not have, the voltage there we do not have. Let's find the voltage there. Let's find the voltage there. We can find the voltage, guys. Remember, the V total, the one the battery supplies, it supplies the, it is divided to the series resistor plus the parallel resistor. So out of this 12 that the battery supplies, it gives a portion to this one, which is, we already know the portion, which is 4.8, and then the remainder out of that 12, it's used by the parallel. So when it's used by the parallel, it's going to be for that. It's going to be for that. Let's go and see how much is that. So we have 12, which is the total. The series there, it used there 4.8 there. Right, just to confirm, yeah. And then we wanted the voltage in parallel, so it will be V parallel is equal to 12 minus 4.8. It's going to be 7.2 volts. So this simply means that the voltage here in parallel, it's 7.2 volts. Even here, it's 7.2 volts. The total there is what? In the parallel, it's 7.2 volts. Remember, parallel, the voltage is the same. So now, having all these things we have, so there's a formula that we can use for energy. Energy is equal to V squared divided by R times delta T. So that formula, we calculate the energy. We have the voltage there, it's 7.2 squared divided by the resistance. The resistance there is, they didn't write the resistance, it's 6 ohms. So divide by 6 times by the time, which is 120. So it's 7.2 square divided by 6. We multiply by 120. It will tell us the energy there. So it's 1036.8 joules. That's the energy. Let's see if we can do the alternative there. There's a formula of energy that says energy is equal to I squared times R delta T. But we do not have the current there. Let's use this one. Let's check this one that says I is equal to V times R. VI times delta T. We do not have the current, but we can get the current there, guys. Let's see, it's not the next question, no. Okay, you see, for these two formulas, you have to first get the current there. So getting the current here, guys, getting the current here, you can get the current because of the voltage that you just got now. So you can get the current like that. You can say I is equal to V over R. So which is, it's going to be the voltage there, it's 7.2, and then we divide by the resistance, which is 6. We'll say 7.2 divided by 6, it's 1,2. So the current that passes in the 6 ohm resistor, it's 1,2. Alternatively, you can get the current there. So we'll say I6 ohm is equal to resistance of what, which is it's R2 divided by R2 plus R1 times by the total current there. So out of the total current, I want to know which one is R1, but I said R2 there. It's very important. So it will be 4. R2 is 4, right? I'll say 4 divided by 4 plus 6, which is the total, times by the total current, which is the total current. What was the total current? It was 3. It was 3 times by 3. So if you punch that in the calculator, it will be 4 divided by 10, which is 10, it's 4 plus 6, times by 3, it's 1.2. It gives the same as this. Very important. So now, having the current, you can utilize any. So the energy, to calculate the energy, is going to be V, which is the voltage there, it's 7.2, times by the current, which is 1.2, and the time, it's 120. It was 2 minutes. So it's 1.2 times 120 times 7.2. It should gives the same. Yes, it's 1036.8 joules, right? Guys, let's go to the last question. That's not the last question. In fact, it's the other question. It says, will the reading voltmeter 2 increase or remain the same if the 4 ohm resistor is removed? Give reason. When the 4 ohm resistor is removed, this one, when the 4 ohm resistor is removed, the circuit becomes series, right? So the circuit becomes series, and the voltage is divided, which is the total is divided among the series, it will be divided to this and this, right? The voltage will be divided to this and this. So which one are they asking? They're asking now, will the voltmeter reading increase in V2? The V2 is 4.8 now. The V2 is 4.8. So if it's 4.8, guys, you can even prove it by calculation. So the voltmeter reading here, guys, it will be you will have 6 and you will have 1.6. Now this 12 will be divided amongst the series, because the circuit now will become what? Series. It will be like this, the circuit now. So you have a series circuit, so you have this voltage is 6 and this one, right? So what we can do now, so this 12, what I was saying, this 12 will be divided among this, né? But what we want to know is this voltmeter reading will increase or decrease. That's what we want to know there. So having that this is what we're going to calculate. That we can calculate by saying, okay, let me do it here. Prove it by calculation. By proving it by calculation, and then we'll explain it. We don't have to prove it by calculation. So we can say V2 is equal to a 1.6 resistor divided by a 6 divided by 6 plus 1.6 times by 12. Okay, so it's going to be 1.6 resistor divided by 6 plus 1.6 multiplied by 12. We want to know out of this 12 ohm resistor, what is the resistance? What is this resistor? What is this resistor is going to get? So the resistance there, it's 1.6. We divide by the resistance of 6 plus this resistance here, and then we times by 12. We want to know out of 12 what is going to be that. So let me write it, the formula. It's like this. You say this is R3 divided by R, this is going to be R, just R, let's say this is going to be R1 plus R3 times by the total voltage. So it's going to decrease. It's going to decrease, right? It's going to decrease. So the answer here is decrease, right? The answer is decrease here, because now the answer, I didn't show you guys the answer. The answer is 2.5.3 volts, which is the voltage there. Now the voltage here, it was what? It was a 4,8, right? It was 4,8, and then alternatively we can say 6 divided by 1.6 plus 6 times by 12, which is, it should be the difference there, yeah, plus 2.53. Yeah, guys, do you see it has decreased there? What caused that? The answer is decrease. Now, since now the total resistance of the circuit, since the total, now we'll say, since the total resistance of the circuit now has, what was the total resistance now? It was 4, right? Now the total resistance of the circuit, it will be 6 plus this. Since the total resistance has increased, and therefore the total current, will what, will decrease. So if the total current decreases, if the current decreases, and the voltage will what, will decrease as well. So which is this voltage. So the current that passes here, guys, the current that passes here will be smaller. So if the current that passes here is smaller, that means that the voltage will be smaller as well, because of Ohm's law. Ohm's law says the current and the voltage are directly proportional. Guys, let me repeat it. Since the total resistance will increase, because now it's only series, it's this and this, so it's 1.6 plus 6, it's 7.6, which means the total resistance increases, because initially the total resistance, it was 4, now it's 7.6. So if the total resistance increases, the total current decreases, which is here, there's a total current that passes here. So the total current there, it decreases, and then the voltage will decrease because they are directly proportional. That's what you're saying there. Now let's go to 6.2. An electric stove is rated to 2000 watts at 250 volts. So this is the power of the stove, and this is the voltage that it uses. Right, this is the voltage that it uses. The electrical company charges 120 cents per unit, which is, this is the cost per unit. When you buy electricity, 1 unit, it's 120 cents. Now the question is, define the term, define in words the term power applied in physics. The power, guys, is a rate in which energy is transferred, right? It's a rate in which the energy is transferred. That's the power. You can even define by the formula that says P is equal to W over change in T. It tells you that's the rate in which the energy is transferred. Now it says calculate the cost of electricity per week, which is, the week is going to be 7 days if the stove is operated 2 days per week. Now let's go to that, to 2 hours per day. 2 hours per day. So we'll say 2 hours times by the 7 days, which is going to be what, 14 hours. So it's operated for 14 hours, because per day it's 2 hours, and how many days? It's 7 days, so it's going to be 14 hours. All right. Now, guys, when we calculate the cost of the power, it has to be in kilowatts. So 2000 watts, you have to divide 2500, you have to divide by 1000. So it's going to be what? It's going to be 2.5 kilowatts. It has to be in kilowatts. So in 6.3.2, we calculate the cost. Cost is equal to power times time times cost per unit, right? So the power, guys, as I told you there, it was 2500 watts, and then I divided by 1000, it's 2.5 what kilowatts. And then the hours, it was 14 hours times 1 rand. That was 1 rand. The cost per unit, it was 1 rand 20 cents, so it's going to be 1,2, right? So it's 2,5 times 14 times 1,2, so it's going to be 42 rand. It's 42 rand. That's the cost of the electricity at that amount. I hope that makes sense, guys.